Alright, so welcome to Cloud Computing. My name is Vasilios Adamos. If you can't be bothered to spell all this out, you can just call me Vas. Alright, I will be your lecturer for this unit. My office is in Anglesey building, on second floor, second room, second office of the second room, A202B anyway. You will almost never find me there because I live in A2.net. A2.net is our networks lab. Okay, so if you look at the timetable of the lab on the door, that's pretty much my timetable as well. So I'm there pretty much all the time. This semester, I think every day apart from Tuesdays. So if you need something, the best way to contact me really is either drop by the lab and ask me something, or you can send me an email to my email address, which is what everybody's email addresses are here, which is name.surname@port.ac.uk. Okay. Now, the unit itself, we will have 3 hours in the labs and we'll have a 1 hour lecture every week as well. The 1 hour lecture will happen on Mondays, usually. There are 2 weeks in the teaching block that's going to happen on a Thursday. One of them is today. The other one is the week starting around the 10th of March, if I remember correctly. Because we don't have space for the lecture on a Monday. Okay, every other week the lecture will happen on a Monday. It will be at 11 o'clock in the morning, and the venue of that will change as well. So it's not always going to be in here. We might be in other places as well. The reason for this is very simple. There is too many of you. All right, so it's a matter of room capacity, really. So always be careful and make sure that you check on your timetable every week, A, if the lecture is taking place on a Monday at 11 o'clock in the morning, B, where it actually takes place so that you don't go to the wrong place and be all alone. Okay. The lab sessions themselves will always happen in A2.net, so that's one less thing for us to worry about. Your lab sessions are scheduled on Wednesday mornings, Friday mornings, or Friday afternoons. Now, you will notice that some of your friends or whatever might be on a different lab session than you are. I am having a bit of a problem this year because on paper I'm supposed to have 154 of you, and my lab capacity is 48 computers. Times 3 gives us 144. So that leaves us with 10 students that don't fit. I'm not too worried about this because usually there is a percentage of students that tend to apply to the university, get registered, pay their fees, and then never show up. I think it has something to do with the visa entry in the country or something. Anyway, I'm hoping that 10 of these students will never show up. All right. If they do, it's a problem for another day. We'll deal with it. All right. If we do get more students, I will create one more lab session, so it's not a problem. Okay. So it's very important that you show up at the lab at your timetabled slot. Okay. You might prefer to be on another timetable slot. Okay. You might be working or traveling or whatever. However, I really cannot accommodate any changes this time around. Okay, let's let the labs run for a couple of weeks, see how many people show up. All right, and then after a couple of weeks, I could possibly move some people around. If you do think that you would like to be moved around and you have an incredibly serious reason for this, let me know when you come to the lab, and I will sit you on a computer that I sit students on specific computers. Like I start from one side on the one session, I move to the other side on the other session, and so on. So I will sit on a specific computer so that you can possibly move and still work on the same computer in the other group that you'll find yourself. This is because when we come into the labs, we allocate computers to students and we allocate usernames to the students as well. So in A2.net, when you come, you will always work on the same computer and you will always log in with the same username every week. This is because you will build the system. In our case, you're going to build your own little cloud, and you'll need to work on this throughout the entire semester. And you, of course, need to be working on your own work and continue working on your own work every week that you come in. All right. So 3 hours in the lab. The lab is open access as well, so you will be able to come and work outside of your allocated lab time if you want to, if you wish, if you need to make up for some time that you might have lost, if something went wrong, for example. But that's something that we'll talk about in more detail later on. Now, the module itself is assessed by Logbook and exam. They're each worth 50% of the unit. And the operating system that we will be using is CentOS 7, and the cloud software we'll be using is OpenNebula version 6. All right. Hands up if you've used Linux before. All right. Promising. That's fine. Okay, if you haven't used Linux before ever in your life, this will be a slightly steep learning curve. Okay, in all probability, if I see that a lot of you are struggling with the initial steps, I will upload some more material as well to help you familiarize yourselves with the operating system. So a little bit of the commands, where all of the files are basically located, and what everything does in the operating system. All right, so don't panic yet. Everything that you need to know about the module is on Moodle. The unit has been revealed magically a couple of hours ago. Okay, so you should be able to see it once you log into your Moodle account now. And hopefully by the end of tomorrow, I will most probably upload all of the lab sheets as well. So the unit will be complete there, and you'll be able to see everything that you will have to deal with for this semester. So the lab itself is called A2.NET. So all of the names mean something in a university. So now we're in RBL2, so Richmond Building Lecture Theatre 2, hurrah. A2.NET is slightly weird because we just put a net in the end because it's our networks lab and we're so cool. It's Anglesey Building, second floor. When you go up the stairs, go left and left again. You can't miss it. It's a big lab on the left side as you're working. Okay, there are two doors, just to confuse everybody. They're right next to each other. We never use the door on the left, use the door on the right. Okay, this is because there were two labs and we just basically joined them, but left the door there just for fun. Lab times, 3 hours per week plus open access. So yes, you can come and work into the lab even outside of your timetabled slot. However, this will have two problems. One, all right, I'll tell a joke next time. So one is I won't be in the lab to help you. All right. The second one is the lab is extremely busy. All right. So apart from this module, there's another second year module that I'm running. The first years are running 4 lab sessions, and there's Yanis and Rinat running more units as well. So I will put the timetable of the lab itself on the door of the lab. You can take a photo of it if you like with your phone, so you will know when labs are running in there, so when it's busy. You can always go in and work on your computer as long as your computer is free. So if there is another class running, you can go in, be very quiet, make sure you turn your phone off, and don't make jokes with each other and cause a disturbance in general, and you should be fine to just sit on your computer and work if your computer is basically not being used. All right, of course, if somebody else shows up and they tell you, I'm in this lab, they take priority. All right. The lab is open from 8 o'clock in the morning until 8 o'clock in the evening. Depending on the caretaker's mood on the day, they might let you stay until 9 if they see that you're really stressed and everything. So, it all comes down to your acting skills in the end. And you can go and work in whenever you like. Weekends, it's closed, I'm afraid. So that's that. So you will be working as one student per computer. So all of the work that you will be doing is individual work. Of course, this doesn't mean that you cannot help each other, whether we're in the lab in a timetable slot or outside of it. I have managed to get quite a few teaching assistants this year, so there should be 3, maybe 4 of us in the lab helping you out per session. But even if if you're working next to your friends and everything, you can share information, help each other out. Don't forget that if you do help somebody else with their work, then you're learning as well, because you'll be able to troubleshoot their system, so that gives you more experience over whatever it is that you're dealing with. We draw the line at the logbook. So you can help each other as much as you like, and your work and your computers can be as similar as you like. Due to the nature of the work and the configuration that we make, there will be lots of similarities between all of your computers. However, we don't want to see lots of similarities in your logbooks. We would expect the screenshots, the documentation that you take while you're working for your logbook, to be different between each person in the lab. And even more so, we would expect the explanations under those screenshots to be worded differently. Yes, the explanation will probably be the same, and depending on what it is, you might not get too much choice about what you actually write. But if I see that you have same screenshots, same wording across multiple computers, then that's a red flag going up, and I will tell you about it. You might also think that, dude, there's 150 of us, how will you know? Unfortunately, I've been doing this for 17 years, so I will know. So last semester, for example, 6 MSc students had the brilliant idea of all submitting the same screenshots. And there was one screenshot with a command that I never taught. And when I asked them, what does that screenshot do? They were like, it was in the logbook. So as you can probably tell, this didn't really go well for them. Yeah? So try not to copy off each other. Try to help each other as much as you can. The idea is that you understand what's happening. I would prefer it if you submit to me a logbook that only contains the first 2 lab sheets, and you have a full understanding of everything that's happening in there, and you explain everything well, and you pass the module, rather than you have a logbook that looks brilliant, has everything inside it, and you have no idea what's going on in there. Okay, it's much, much better for everybody. Also, of course, if you do get stuck at some point and you don't understand the technology, you don't understand the theory behind everything that we're doing, always come and ask me. Okay, our job in the lab is to help you understand everything that's happening and not just help you to complete all the tasks and rush to the end. All right, so it's very, very important that you actually understand what's happening rather than making a great progress and finishing all the lab sheets and so on. Okay, so always ask me. I am here to help. I'm getting paid well enough to help everybody. All right, and so are the lab assistants for that matter as well. All right, so don't be afraid to ask. On the other hand, don't be afraid to try to experiment by yourself on everything that you're doing. So you can try a configuration out. If it doesn't work, we can fix it. Even if we can't fix it, you will be working in a virtual machine that we can restore for fun. So it doesn't really matter. You're not going to really cause irreparable damage. As the networks go, you're isolated in a lab that's isolated from the rest of the world. You cannot really do anything networking-wise to affect the rest of the university, God forbid. And really, you can't really mess with the operating system itself because it is a virtual machine. So if you break it, we'll just recover it. And it doesn't really matter. Okay, so don't be afraid to experiment and make sure that, once you've reached your limit of, okay, I cannot do this, I don't understand this, always call us so that we help you out with whatever it is that you're doing. So you will get allocated computers and user accounts. So the first day that you will be in the lab next week, I will tell you all to sit on whichever computer you like, depending on the location and the lighting of the room or whatever you like. I really don't care. And I will give you a username and a password. The username for you will probably be something like VM7 or VM8, something like that. The password is always localhost 1 for everybody. The first thing that you'll need to do once you log in, and that's in the lab sheet as well, will be to change your password. You need to change your password because if you leave it to localhost 1, someone could accidentally or on purpose log in with your username and mess everything up. Okay, if you change the password, the computer and the username on that computer is now yours and nobody can do anything to it. All right. Also, it's a big lab, 48 seats and everything. When you leave the lab, try not to leave a mess behind. There is no food or drinks allowed in the lab unless you have like a bottle with a cap on it. The criterion is that you can flip a bottle over your head, and if you're not wet, you can keep it in the lab. Yeah. If you do make a mess, please tidy up because we have no cleaners coming in that lab. It's just me, and I really don't like working as a cleaner. Also, another thing that I discovered after the pandemic when all the students came back, please put your chairs back under the desk. Yes? Because, we'll leave the lab and it's like a bomb has fallen in the lab and there's chairs everywhere. All right. So this just messes with my OCD, really, so please do it. Logbook in detail. So, it's an electronic logbook, so it will be essentially a Google Doc that you will have to create. You will need to document all of the work that you do in the lab, which means basically take screenshots. There is a case snapshot utility in Linux that students tend to use. You can grab a screenshot of a configuration file or anything else that you've configured on the operating system, put that screenshot in the Google Doc, and then write a few words underneath it explaining what you did and most importantly, why you did it. All right. This can be as detailed as you like. It can be a very thorough step-by-step process that takes you 300 pages in the logbook to explain. I'm okay with it. Do whatever you like, it's fine. Or you can be, as frugal as you like, as long as the key points are there. So if you're setting up a service, all of the configuration changes that you've made to get the service to run should really be in the logbook and explained why it's there. Now I do have a sort of example structure of the documentation that you should have it there, preparatory work, methodology, testing results, and so on. You can adhere to that if you like, or you can just follow the methodology of the lab sheet itself and just explain everything as you do it. Whichever way you like. Always remember that when you're working in the labs, it's the best idea to take screenshots as you're doing stuff. So if you're doing something, don't just complete the task, wait to see if it works, and then go back to take screenshots, because it might not even be possible as well. All right. If you do something, take a screenshot, save it in a folder, or throw it in Google Doc, and move on. Because it's a Google Doc, I would prefer that you use Google Chrome for best compatibility with this in order to put the screenshots in there. Another thing that I want you to do is when you come into the lab, you will start up the virtual machine that you will be working in. So I want you to come into the lab, log in, start the virtual machine, set it to full screen. You can then go on to the browser, you can go on to Google Chrome, and you can go on to Moodle and your Google Drive. You can save your passwords in there because nobody else is going to log in with your account on that computer, and we delete everything at the end of the semester anyway. So you can have quick and easy access to your logbook and to the lab sheets on Moodle in Google inside your virtual machine. Now in the past I've had lots of students working, starting up the browser outside the virtual machine. That causes a problem because you cannot copy and paste stuff correctly. You definitely cannot take screenshots and copy and paste them onto the Google Doc, and you cannot copy and paste commands. So for example, I have a lab sheet, which is the obvious networking, when you set up the networking in your cloud, that it has a bunch of commands, and all you need to do is just copy and paste them into a terminal, and voila, the thing works. If you try to copy and paste them outside the virtual machine, the little minuses on the switches on the commands don't really get transferred correctly, and they get transferred as longer minuses, and the thing just doesn't work. Okay, so little weird details like that. The virtual machine that you will be working in, I have prepared already. So the students in the previous semester had to build their own. So now I've built one myself. I've prepared it in whatever way it was necessary. So I have disabled SE Linux. I am taking IP tables out, and I've installed Google Chrome, and I've made it run as user root, and I even put Moodle as a shortcut on the bookmark for you. So it should be very easy to just come in, log in, start the virtual machine, full screen it, and just work in there. You don't need to do anything else. Okay. If you work on your logbook like that, then you can work on it every week when you come into the lab, and at the end of the teaching block, in the last week, I think it's something like the 12th of May, 11th, 12th of May, I will come and sit with you on your computers, and you need to show me your logbook. You need to have a few things running on your screen, on your cloud, and I can have a look at the work that you've done on the computer and what you have on the logbook. And if I'm happy that they both agree with each other, then I will give you a nice mark and you can be on your way. All right. My mission is to give you all A, so you have to help me with this. As for the other artifact that this module gets assessed in is the exam. It's going to be a computer-based test. So basically, you sit on a computer at the university somewhere, you open a browser, and 50 questions show up, and you have an hour to complete them. 50 very short questions show up. You won't need to do calculations and things like that. The time and location for this will be confirmed when the exam timetable is out, which usually happens sometime in March. The exam period this year is running for the last 2 weeks of May and the first week of June. So basically we finish the exam period on the 3rd of June. So if you need to book tickets to get out of here and, for example, go to Greece, please do it after the 3rd of June. All right, so make sure, because I understand that, if you book tickets, you need to book them as early as possible. Make sure that you are here for the exam period. Even if you don't have any exams in the last 2 weeks, it's worth it. Okay. The questions in the exam will be multiple choice, multiple response, fill in the gaps, and so on. The fill in the gaps ones are the ones that are the most tricky ones, perhaps, because I might ask you to, type a command to do something. However, the exam is open book, which means that you can have a double-sided A4 page with you, and depending on how small letters you can write or print, you can even bring a magnifying glass with you if you like for a lecture. You have your entire logbook in 2 pages of A4. Okay. You will find that unless you know what you're actually doing, it won't help you much. The exam tends to be quite difficult because the logbook is quite easy. So I have to balance things out a little bit and figure out, who knows stuff and who just got lots of help in the lab. Okay. So yes, if you do your logbook and you progress with all your tasks and you actually learn what you're doing in the lab, then you shouldn't really have any problem in the exam either. So what we will be dealing with is we're dealing with virtualization in general. So in computing, virtualization refers to the act of creating a virtual rather than actual version of something, whether that's an entire computer or whether that's a CPU cores or amount of memory for processing or hard drive space for storage and so on. So what we'll be dealing with here is the evolution of this principle, which is cloud computing, which will essentially allow you to virtualize resources that you can use in order to go about your business. Why is this all useful? You can be running multiple operating systems at the same time. So you can have a cloud that runs lots of virtual machines, lots of virtual servers inside it. You might have software, or you might have requirements from your users in a company that require a specific operating system or a specific program that requires a specific operating system and doesn't run in another. So you can have a variety of operating systems to be running in your network, and it doesn't really matter because they're all virtual machines sitting on a server somewhere or sitting on a data center somewhere, and you can just run them and do whatever you need to do with them. It gives you easier software installations because you can do backups, you can do recoveries, and you can experiment with software, and then you can have snapshots, and if it doesn't work, you can go back. So it's much easier to generally install software without worrying too much about breaking the server itself. You can also build a test environment, so it has better testing and disaster recovery. So you can build a copy of a virtual machine, test something on it, and if it works, then you put it into production. If it doesn't, then you just delete it and make another one. It doesn't really matter. And of course, it provides infrastructure consolidation. Instead of having endless space of data centers and endless actual hardware being cooled and powered and everything else, you can have a smaller infrastructure in your company. You can have no infrastructure in your company if you're using somebody else's cloud, in fact. So cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. So all the user needs to do is sit in front of the monitor on a computer that's really not very powerful, have a connection to your cloud, have certain rights, being able to start up and use various resources in that cloud, start them up, use them, and go about their day. So for example, you can have a researcher in a company in a big pharmaceutical company, for example, and they're running some simulations, some experiments. They generate lots of data. They need lots of CPU power, possibly, for some simulation that they might be running. And you can provide them all that by configuring some software in your cloud to do that for you. So when they say, okay, I'm gonna run a big simulation and it needs 10 CPU cores instead of one, you don't actually have to go and bring them a much stronger computer. You can just go into the user management interface and add more CPU cores to the virtual machine that they're using. So it's very easy, basically. So why is it useful? First of all, efficiency. You get accessibility, cost savings, security, and disaster recovery. So it makes the whole day-to-day of running a business much easier and much more flexible. You can have users that can be working from home. All you need really is network connectivity, a stable network connection to your cloud. You can have people working from anywhere in the world, really, and they will still be as productive as if they were sitting and working in their desk back in your premises. This, of course, also gives you cost savings as well, because you perhaps don't need to have people travel around to possibly go into meetings or go to work and so on. You don't need to pay people allowances when you hire them so that they move to a different city. There's lots of options for this. You also have lots of flexibility, so you have scalability, tool selection, cloud options and control choices. As I said, you have scalability, so if you need more power, you get more power, you get more resources depending on what it is that you want to do. And this, of course, always comes down to the cost of everything as well. So if somebody doesn't always need the same amount of computing resources, you can scale them up or down, and it doesn't really matter. So it's not like you're going to buy a very powerful computer for somebody and he's going to use it for 1 month out of the year and then not use it for the rest of the months. So you can scale your system according to the user needs at the end of the day. And it gives any company a strategic edge, so it's increased productivity, you get software updates, you get competitiveness, and you get increased collaboration, all those marketing terms that people like to hear. Because basically the system is so flexible and you can tailor it to your needs as much as you want to, and that will make you essentially more productive and will give you a better value for money for what you're doing in your business. So how are we going to go about building our cloud in the lab? So this week is the introduction. Next week, which our lecture will be on Monday, so like 4 days from now, I will talk about design and installation considerations, and I will go through the first lab sheet, which is the installation of the software of OpenNebula that we will use. We'll then go into the software itself. You'll explore Soundstone, as we call it, the user interface, the web interface for our cloud, and see where everything basically is and what you can do with it. You'll build your first virtual machine in the cloud, so you will see how you go about from creating the hard drives that you need for them, so make the images, create templates out of which you will choose the hard drives that you want to use, and then out of those templates make actual virtual machines by telling them how much CPU, RAM, network connections, hard drive space you need, and then you'll start up that virtual machine and see it running and how you actually can use it in the cloud. We'll also deal with the different states of existence of a virtual machine in the cloud, because you can have a virtual machine as allocated to the cloud and running, allocated to the cloud and stopped, removed from the cloud completely, suspended, and so on and so forth. We'll deal a little bit with networking. We're going to use something called OpenVSwitch. So that's an add-on to OpenNebula that basically allows you to customize the network connectivity of your virtual machines and the entire infrastructure of the cloud to do exactly what you want to do. And in the end, the last lab sheet is essentially building your first cloud. So using everything that we've learned from all of the previous lab sheets, I will ask you to basically build a cloud that has a variety of virtual machines inside it, that they have a variety of purposes in life, and then that is a complete solution for, let's say, a small to medium company that would like to use something like this. Okay, so by the end of this, you should be able to build and manage your own cloud. Recommended reading, if you've never used Linux before, please get the Red Hat Linux 7 Unleashed. You can find it in electronic form as well. And if you're very industrious, you can find it for free as well. And OpenNebula's website has the manual for OpenNebula itself. So if you go to this, it will give you the basic building blocks of what OpenNebula actually consists of, how it actually works and everything else. And you can always return back to this website and use it as a guide, even later on as we progress through the labs, and you can get some information and figure out basically how things work and where everything is. Done. Okay, any questions about all this? So remember, next week the lecture is on Monday, 11 o'clock. I honestly don't remember what it is. I think it's Portland, but I'm not sure. Check it and make sure you know where you're going. All right. And Wednesday morning or Friday morning and Friday afternoon, you need to make sure that you come to the lab sessions. Please try to come on time or like 5 minutes before your lab, because I need to sit you down and decide where everybody sits and where everybody is working. Okay? Any questions? Yes?
Tomorrow is my timetable.
Don't do it. Okay? So there are no labs running in the first week, so I sent you an email about this last week.
Yeah.
They keep doing this to me every year. I don't know. Must be a running joke with timetabling or something. Okay? So I will see you all next Monday at 11. Thank you very much.